Okay, challenge problem day only got to one because it was about quadratics. So we're going to do more about quadratics. Again, I know you missed this last year in Algebra 1, so we're going to keep hitting it and hitting it, hitting it. So here I have a problem on here, x squared plus 9x equals 36. My suggestion is pause this video, try to solve this problem, and then come back and unpause it because then I'm going to show you how to do it. Okay, pause. All right, so we're back. Anytime, early on, the first tool, and we're actually going to discuss that isn't always the case, when we first start solving quadratics, we learn that the best way to solve quadratics is to get it to say equals 0, because then we're going to try to factor. So that's usually our first step. Now, once we do that, we're going to try to factor. So we're going to turn this into x and then some number in the first set of parentheses, and then the second one's going to be x and a different number, and they're going to equal 0 when we multiply them. Now, what we know is these two numbers have to multiply to give me 36, but they have to add up to give me 9. Now, this is where not necessarily having really good arithmetic skills can get in your way, because what are the things that multiply to give me 36? Well, it'd be 1 and 36. 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now what I need is two of these numbers that also can somehow combine to give me 9. Now because this is negative, I know one of them is positive and one of them is negative, so we're finding their difference, and I need ones that differ by 9, and that is right here, 3 and 12. So, and again, I want the 3 to be negative, so it's negative x minus 3, and then plus 9. Now again, the reason for that is because these numbers multiply to give me, I put 9, but I meant 12. These numbers multiply to give me 36, but they add to give me positive 9. So now I have factored. Now I want to know what my solutions are. Well, the first set of parentheses gives me x to be 3. And the second set of parentheses gives me x to be negative 12. So classic factoring, solving by factoring. So here we go. We're going to do another one. So we'll set up another one, x squared. Okay, I think that one will come out nice. So again, if I were you, I would take a second and pause this, try it, and then come back. Okay, so again, we're going to get x, we're going to get everything on one side, x squared plus 17x plus 60 equals 0. We're going to try to factor, so we're going to have two sets of parentheses, and this one's going to be x plus some number, and this one's also going to be x plus some number, and we're going to still equal 0. These numbers need to multiply to give me 60. So what are the things that will multiply to give me 60? Well, you have 1 and 60. You can have 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And again, if your arithmetic skills are a little slow, it's just something you've got to work on. You've got to get these kind of basic facts down. Now again, I'm looking for something that multiplies to give me 60. I know they're both positive because they multiply to give me a positive and they add to give me a positive. So I'm adding them together, and I've got to get 17. So that one's right down here at 5 and 12. So this is plus 5. And this is plus 12. And now I don't need these factors anymore. So my solutions are x equals negative 5 and x equals negative 12. There's my solutions. Now, so far, we've always done things that will factor. Well, there's going to be situations where things don't factor. So what happens when we get into a situation where things don't factor? Well, what we're going to do is there's a couple of special ones, okay? So there's this situation which says x squared equals 49. Well, what are the answers to that? Well, you could actually move it over and factor and you would see the answers, but a lot of people just want to take the square root. They want to say x equals 7. Well, it doesn't just equal 7. X equals both positive and negative 7. Now, we write this with this little plus minus sign. Mathematicians are notoriously lazy. We don't want to write more than we need. So instead of writing x plus 7 and x equals negative 7, we just write x equals plus or minus 7. It means both of them are answers. And again, it's because 7 times 7 is 49, but also negative 7 times negative 7 is 49. This is different than asking for the square root. If I said, what's the square root of 49? The square root symbol implies positivity, so we would only answer positive 7. But because we're saying x squared equals 49, we get both answers. So we're going to use this idea here in just a minute. Another idea we're going to use is something that looks like this. All right, again, I'm going to give you a minute or two. I suggest you pause this and then go try to solve this. And then I'll show you how to do it and we'll talk about how it works. All right, hopefully you're back. Hopefully you got answers. So again, we're going to try to factor this. And we're going to get two parentheses. Again, x in one of the parentheses, x in another one of the parentheses. And then it still equals 0. We need numbers that multiply to give me 25. There aren't a lot, 1 and 25 or 5 and 5. And they need to add up to give me negative 10. And they both, so this is going to quickly, hopefully you'll all get this pretty quick, is clearly both negative 5. And so what I end up with is only one solution, x equals 5. Well, this could have also been written as this. X minus 5 squared, because we only have one factor, actually. We have what's called a double root. We're going to use this as well, because what we can do is we can say, okay, what is x plus 4 squared? Now, I get this answer a lot. See what I did? Nod your head. Okay, this is wrong. This is so wrong, it has a name. It's called the freshman dream. You can look it up. It is a very, very common mistake for freshmen, and I see it every year over and over and over again, and we have to stop. We cannot do this. This is actually equal to, again, squared means multiply it by itself. So it literally means x plus 4 times x plus 4, which when you do that, when you follow the distributive property, you get x squared, and then you get two 4x's, so that's 8x, and then you get the plus 16. So this is actually what it equals. So we're going to take this in the middle part out here. And hopefully now you can see that if I ask you, what is x minus 5 squared, you would realize that that's got to be x squared, and then minus 10x, and then plus 25. Likewise, if I ask you, what is x plus 7 squared, you would know that is x squared plus 14x plus 49. Now, what we're going to do is I'm going to ask you to do this in reverse. I'm going to, instead of giving you the left-hand side, I'm going to give you part of the right-hand side. So I'm going to say I have x squared minus 20x. Now, I want to know what has to be over here on the left. Yeah, I didn't give you everything, but you have all the information you need. Look at the pattern. What's happening over here? What is the relationship between this number and this number every single time? Okay, the relationship is that it's half. So on this side has to be x minus 10. Now, there is a piece missing from over here, and that is plus 100, because that's 10 squared. Now you may wonder, how are we going to use this to solve a quadratic? Well, let's give an example. Let's say we have x squared minus 12x, minus 4 equals 0. I want to solve it. Well, clearly it doesn't factor. The 4 only has 1 and 4, which don't add to 12 in any way, or 2 and 2, which also can't get me 12. So this is not factorable. So the very first thing we're going to do is abandon what I told you is the way we normally solve quadratics. We don't want it to say equals 0. We're actually going to add 4 to both sides, so it doesn't equal 0. So again, what we're doing here is we're taking control of the problem. We're manipulating the problem ourselves. We're forcing it to do something we want it to do. So now what we're going to do is we're going to force this to factor into